Okay, this is Roger Timmerman McLean. This is Manufacturing Processes, Dr. Nasseri's class. We're going to do practice problem number 4 in chapter 4. Now let me show you what the problem says. Basically what we've got is we've got a magnesium block that's 10 by 10 by 10. That's the dimensions. The block is at a temperature of 21 degrees Celsius, and we want to raise that temperature to 400 degrees Celsius. So what the question is asking us is to calculate the amount of heat energy is going to take to raise that temperature from 21 to 400 degrees Celsius. Alright, so let's get started. I did a brief setup here on the board, just visually, so we know what's going on. What we've got is a magnesium block. It's 10 by 10 by 10. It's at 21 degrees Celsius. What we're going to do is we're going to add heat energy to this block to raise its temperature to 400 degrees Celsius. So what the question wants to know is how much heat do you have to add to that block to get it to 400 degrees? This problem is straightforward once you know that the equation for heat energy. That equation, heat energy, is equal to the mass times the specific heat of the material. This is a constant that's material dependent, times the change in temperature. So heat energy is mass times specific heat of the material times the change in temperature. To get started, let's look at the mass here. We know from previously that density, rho, is mass per unit volume. So that tells us that mass is equal to rho times volume. Sure you can see that. Yes. So mass is equal to rho times volume. So what we could do is we could just substitute back into our equation. So we've got heat energy is equal to rho, density, times volume, times specific heat of the material, times the change in temperature. Alright, so let's see what we've got here. Well, density is this is actually a property that we can look up. Density of magnesium. This is actually a material property that you can look up. And in our text, that property is in table 4.1. The density of magnesium is in table 4.1, and that value is, looking that up, writing that in here, it's 1.74 grams centimeters cubed. Our volume, we know it was given. They told us the dimensions of the blocks, so volume is depth times width times height. So volume we know. C, the specific heat of magnesium, that's another material property that we can look up in tables, and that's in tables 4.2 of the text. And that, let's just write that here, C is equal to, I just write it here so make sure you can see, C is equal to 0.25 calories per gram degrees Celsius. So this is our equation we're working with. We know density, we know volume, we know specific heat, and we know the change in temperature. So we've got all the information we need to just plug in. And let me put it in here. Heat is equal to rho 1.74 grams centimeters cubed. Volume, it's 10 centimeters by 10 centimeters by 10 centimeters, so that's 1,000 centimeters. cubed. Specific heat of the material, look that up. Degrees Celsius. Times the change in temperature, we're going to go from 21 to 400. So the change in temperature is 379 degrees Celsius. Make sure you got that there. 379 degrees Celsius. Okay, so let's make sure our units work out. Celsius is going to cancel that Celsius. These grams are going to cancel out these grams. And centimeters cubed is going to cancel out centimeters cubed, leaving us with calories. And calories is a unit of energy, so that works out. And that's going to be 164.865 calories. Now, generally, energy is expressed in joules, so we can do a conversion and convert calories to joules. So we'll go ahead and do it here. We know the conversion. Sure, you can see. I'm just gonna write this up here. What the conversion is to go from calories to joules. We know that we've got 4.184 joules equal 1 calorie. Just gonna write that in here. Conversion. So 4.18 joules equals 1 calorie. So we'll go ahead and convert right here, and we're just gonna say 164.865 calories times 4.184 joules per calorie. Sure you can see that. All right, so that's good. So calories are going to cancel out, leaving us with joules, and our answer is going to be, the heat energy is going to be 689,795 joules of energy. So essentially, to move the temperature of a 10 by 10 by 10 feet cubed block of magnesium from 21 degrees Celsius to 400 degrees Celsius, we've got to add 689,795 joules of heat energy. Pretty straightforward problem. Just practice it, just using the heat energy equation. Hopefully this answers any questions you had on this problem.